Welcome back. So in the companion video to this, we looked at what a rational expression was, what are non-permissible values of a rational expression, so setting the denominator equal to 0 is not allowed, and how to find those restrictions or non-permissible values. So what we're going to look at now is simplifying rational expressions, and to simplify them we're going to look for any factors that are in common in the numerator and denominator. And then we're going to divide those until there's no common factors left, realizing that we have to keep up with this restriction that we cannot make the denominator equal to 0. So we're going to simplify 3x plus 3 divided by 6x squared subtract 6, and we're going to state any restrictions. So looking at this expression, I see I have a common factor of 3 in the numerator, so let me factor that out. I'll be left with x plus 1. In the denominator, we have a common factor of 6, so let me factor that out, and now we're left with x squared subtract 1 in the denominator. Now our numerator has been fully factored, but our denominator has not. 6 can factor down into 3 times 2. I would consider that step optional. X squared subtract 1 is the difference of squares, so that's the same thing as saying x plus 1 times x minus 1. And now we've fully factored our numerator and denominator, and we're going to look to reduce any factors that are in common. But before we do those reductions, this is the time to look for any non-permissible values which exist in the denominator. So if we look at x plus 1, if that expression were equal to 0, then we would have a denominator that's equal to 0. So we cannot have x plus 1 be equal to 0, which leads us to the restriction x cannot be equal to negative 1. Similarly, if the expression x minus 1 was equal to 0, that would set our denominator equal to 0, so that is also not permitted. And that will lead us to the restriction that x cannot be equal to 1. Now, as you're going to see very shortly, it is important that we find any restrictions that exist before we fully simplify the expression. Let's now simplify this factored expression. So we have a 3 in the numerator and a 3 in the denominator. 3 divided by 3 is equal to 1. We have x plus 1 in the numerator, and we have x plus 1 in the denominator. X plus 1 divided by x plus 1 is also equal to 1. So what is left in this expression? Well, in the numerator, there is no longer a factor of 3. There is no longer a factor of x plus 1. So the only factor that remains in the numerator is 1. In the denominator, there is a factor of 2 that remains, and a factor of x minus 1 that remains. So this is 2 times x minus 1. What were the restrictions? So checking back to the work we did earlier, x cannot be equal to negative 1 or positive 1. Now you can see why we had to find those restrictions on the previous step before we started dividing and simplifying terms. If we were to only look at our final answer, then this x minus 1 in the denominator would lead us to one of these terms, but it would not lead us to the other one, because this second restriction of negative 1 was factored out in this step. But both of those restrictions still exist in the original denominator. You can take a look here that if I put in x equals negative 1 in for x squared in the original expression, I would get 6 times negative 1 squared, which would be 1. So 6 minus 6, which would be 0, which would turn that denominator into 0. If I put a positive 1 into this original denominator, I would get 6 times 1 squared, so I would get 6 minus 6, that would also be equal to 0. So we can see that both of these restrictions are valid, but by the time that we have simplified the original expression, we only have one of the factors that remains. But in the original problem that we were given, both x equals negative 1 and x equals positive 1 are restrictions for this problem. So it's important that you find those restrictions before you try and simplify and divide any of the common factors. Okay, let's look at another problem now. So for this problem, we seem to have a much more complex expression. So 4c squared minus 8c divided by the expression 4c cubed minus 4c squared minus 8c, and we want to state any restrictions. Okay, so the important thing is that we want to fully factor both the numerator and the denominator of this expression. So looking at my numerator, I can see there is a factor of 4 and a factor of c that can both be factored out of this expression. When I do this, so if I factor 4c out of 4c squared, I'm left with c. If I factor 4c out of negative 8c, I'm left with a negative 2. So my numerator, 4c times the expression c minus 2. Denominator, well, there is also a 4 that is common to each of these three terms, and there is also a c that is common to each of these three terms. So what is left when I factor 4c out? I have c squared, subtract c, subtract 2. So I factored 4c out of the numerator and denominator. Is there any more factoring which can be completed? Well, this denominator will factor a little bit further. So c squared minus c minus 2. So are there two terms which I can multiply together to give me that expression c squared minus c minus 2? So I believe if you put c plus 1 and c minus 2, that's the factorization of c squared minus c minus 2. So now this expression has been fully factored. And we can start to simplify, but before we simplify, let's look ahead and see what are the restrictions going to be. So c implies that we cannot have c equal to 0. This factor of c plus 1 implies that c cannot be equal to negative 1, otherwise that factor becomes 0. And finally, c minus 2 implies c cannot be equal to 2, otherwise that factor will become 0. So now that we've identified each of these restrictions, we can start to simplify. So we have a factor of 4 in the numerator and denominator. We have a factor of c in the numerator and denominator. We have a factor of c minus 2 in the numerator and denominator. So what is left? In the numerator, we are once again only left with a factor of 1. In the denominator, we are only left with a factor of c plus 1. So 1 divided by c plus 1. But we must list each of these restrictions, and we'll list them from the least to greatest. So c cannot be equal to negative 1, or 0, or 2. Note that these two rational expressions are equivalent. So these are equivalent rational expressions with these same restrictions, that c cannot be negative 1, 0, or 2, because that would cause the denominator of the original unsimplified expression to be equal to 0. So putting in any of these three values into 4c cubed minus 4c squared minus 8c would cause that denominator to be equal to 0. Note, but by the time we have simplified this expression, we can only observe one of these three restrictions, but all three of them would be non-permissible in the original expression. All right, final problem. We have the expression 10a squared plus 20ab, which we're going to divide by the expression 2a plus 4b. We want to simplify that, and we want to state any restrictions. So what factors are in common in the numerator and denominator? Now you've noticed that this does not just include one variable like our previous problems, there are multiple variables. So in the numerator, I can see that we have a factor of 10 in common, and we have a factor of a in common. So if we factor 10a out of the first term, we're left with a. If we factor 10a out of the second term, we're left with 2b. In the denominator, we have a factor of 2 that's in common. If we factor 2 out of the first term, we're left with a, and if we factor 2 out of the first term, we're left with 2b. Now, before we start simplifying, we need to observe the restriction. In this case, we have this expression, a plus 2b, which is not allowed to be equal to 0. We're not going to have one unique value or several unique values, but this time we're going to have a range of values. Anytime that a is equal to negative 2b, it's going to give us a non-permissible pair of values. All right, time to simplify now. So 10 divided by 2 will leave us with a factor of 5 in the numerator. And we have a plus 2b divided by a plus 2b, which divides to give us 1. So our answer is 5a. Everything else has simplified, but it's only 5a if a is not equal to negative 2b. Because when I stated earlier that a plus 2b divided by a plus 2b is equal to 1, that is only true when a is not equal to negative 2b, because if it is, that will set our denominator equal to 0, and we're not allowed to have 0 divided by 0. So, our final answer, 5a, with the restriction a cannot be equal to negative 2b. I solved it for a in this case. It also would have been fine if you had solved this for b. In this case, I believe we would have had b cannot be equal to negative a divided by 2. This would have been okay. You only have to list one of the two pairs. Your teacher may force you to list one of these over the other. So for example, they might say, state the restriction in terms of A, in which case you would have to show the first one, or state the restriction in terms of B, in which case you would have to show the second one. But only one of these two is necessary. Okay, so that's an overview of simplifying rational expressions and listing their restrictions.